So we proceed to the components of a microprocessor. So a microprocessor has the ALU, the arithmetic and logic unit, which performs arithmetic and logic functions. When you talk about arithmetic, we are talking about things like addition, subtraction. Let us write. When you talk about arithmetic, you're talking about addition, you're talking about subtraction, you're talking about multiplication, and you're talking about division. And then when you're talking about logical operations, what you should be thinking about is things like comparison, comparison. You have comparison, and then you have a decision making process. Decision. You have decision making process. So that is what comprises of the ALU. So after the ALU, we have something else called the control unit, which can be written as CU. This is the control unit. Control unit. The control unit will control the performance, the execution of instructions. It is more of a, from the word control, you think when someone is controlling something, they are probably managing and coordinating. So whenever you hear of a control unit, think about managing and coordination of the operations to be performed. So the control unit manages and coordinates the operations from all other components of the system. So the control unit essentially will make sure that everything in the system is working as it should be, smoothly and in a reliable way. And then we can proceed to the next thing, which is registers. Registers they are small high-speed storage. Whenever you think that they hold data for a temporary time, but we're not talking of the memory in terms of RAM. With registers, it isn't a memory in terms of RAM, because microprocessors do not have memory, but a register will behave like a memory. So in the sense that it is a high speed and small sized storage. It is high speed, it is small sized, and it is very temporary. And when we go to the specific 886 microprocessor, we're going to look at the different types of registers. Then we have the cache memory. The cache memory is another type of temporary memory, but its difference with a register is that it stores what is commonly accessed. So it will enhance the speed of and performance. Enhances speed and performance. It will enhance speed and performance because if it sees something is being frequent I've been talking a lot, most frequently used data. So if something is being accessed a lot for a microprocessor, it is automatically stored here. Remember, what I said that the microprocessor does not have a memory, I meant in terms of RAM. But the microcontroller will have memory in terms of it has its own thing that we can call a RAM. In that, you see this is a microcontroller. It is already self-contained in its own way. Is it visible? It is already self-contained in its own way. In that, when I run code here, when I upload code here, it stays here. Like, if I upload code and I say pin 13, have a high, in that so that my LED can light up. So even if I disconnect, so long as I have another power source here using a battery, and I disconnect my thing from the computer, this thing will still continue working. So long as it has a power source, this microcontroller will continue working because it has what you call a memory, a RAM. It has a RAM. But if I take my Intel Core i7 or my Intel Core whatever, and it cannot do anything else because it needs peripherals. Do you get me? So when I say that a microprocessor has these types of memory, I mean when that these memories are helping it when it is in execution, but it has no ability to run on its own. It needs peripherals, not like a microcontroller like this one. It needs peripherals. This one already has its own memory that will remember, oh, I uploaded a certain code. A microprocessor does not. That is what I mean. So do not get confused. Then for a cache memory, I had already covered that. So among the other components of a microprocessor that you're going to see when you get to the Intel 886 is something called a clock generator. Generator. So whenever you think of something, so of a clock generator, this one's work is to synchronize. So clock generator, so there will be something to do with synchronizing all components and operations of a computing device. All components and operations of a computing device. So the clock generator is an electronic circuit. It is an electronic circuit, and this circuit will generate clock signals so that it can be able to like define the operational speed of the microprocessor. That is the work of the clock generator. So it will synchronize all components and operations of a computing device. And then the next thing you're going to say, it defines. It is an electronic circuit. Say it is an electronic circuit. It is an electronic circuit that can generate a timing or clock signal. Then when it generates this clock timing or clock signal, this clock signal will define the operational speed of the microprocessor. Define the operational speed of the microprocessor. Yes. And Now my clock has tilted. And then the next thing you're going to cover is something we are going to call a system bus. A system bus in a microprocessor. This is when you hear of the word system bus, think of a communication channel, a way to communicate, a communication channel. And this communication channel, if it communicates, what's the next obvious thing? Then if it communicates, it should connect various components together because it is communicating. If it is communicating, then it should connect various components together. Various components of a microprocessor together. In such a way that it can provide capabilities for, so I said it is a communication channel. So if it is a communication channel, it connects various components of a microprocessor together. And if it does that, what does it mean? It means it provides a capability. Now this arrow, say, provides, then here we're going to say capabilities for flow of data, for flow of, so it will provide capabilities for flow of data. So here we're going to have data, instructions, and then control signals. So when we expound on the specific microcontroller, the 886, we're going to look at the different types of system buses, like the data bus, the address bus, and the control bus. So that is something that you can expound. We are going to expound that when you go to the next topic. So that is the end of the components of a microprocessor in general.